Hello children. Today we'll be continuing with machines chapter 3 machines, which I started the other day. I gave a little bit of introduction, but today we are going to go ahead of it. Turn to page 49 in your books. Turn to page 49. Okay. So what were you seeing? Some important terms related to machines. So we were seeing about load, effort, okay, then third term mechanical advantage, and fourth term velocity ratio. These are the four terms that we saw. So load is the resistive force that has to be overcome. Effort is the force applied on the machine to overcome this load, and then MA is mechanical advantage. So that will come later. So if I take the example of a scissor, so if I am using it to cut a paper or something, this is the load. The paper is the load and this is the effort. What I am applying is the effort, and this is the, I am working on this, so that will be the load. Okay. Now, MA, so that day we discussed it. We'll have a quick recap. MA is mechanical advantage is the ratio of load upon effort. Is the ratio of load upon effort. Okay. Now, so there are three possibilities. MA can be greater than 1, MA can be equal to 1, and MA can be less than 1. Now, if MA is greater than 1, what does it mean? Load is greater than effort. Numerator is greater than denominator. Equal to 1 means load is equal to effort. Less than 1 means load is less than effort. So in this case, with less effort, you can do a heavy work. So that will be used as a force multiplier. Force multiplier. And this one is used to change the direction. Okay. It is just used to change the direction of application of force. And here, effort is more than the load. Then why is it a machine? Here it has some other function that is called speed multiplier. So I explained you the other day, this paper I can cut without a scissor also. It's not that I need a machine, but with this scissor my work happens faster, because I will be moving my, this is called distance travel by effort. I will be moving my fingers through a lesser distance, but the load would have traveled through a longer distance. That way my work will be faster. So that kind of machines are called speed multiplier. So a machine can either be force multiplier, or it can be used to change the direction of force, and it can also be used as a speed multiplier. Is it clear? Now, the fourth one is velocity ratio. So velocity ratio definition is, actually it is velocity of effort upon velocity of load. But from this, we don't use this. From this we derived another formula, distance traveled by effort upon distance traveled by load. So usually we use only this for velocity ratio. Distance traveled by effort upon distance traveled by load. Again, so velocity ratio can have all three possibilities. BR can be greater than 1, BR can be equal to 1, and BR can be less than 1 also. So if VR is greater than 1, then DE will be greater than DL. Effort moves through a long distance than the load, so it's a force multiplier. Whereas here DE will be, or DL will be greater than DE. In the sense, load will move through a longer distance when compared to effort. So that will be speed multiplier. In this case, it will be used to change in direction. These are the three possibilities that we have. Okay. So this is what we did the other day. Now we'll go to the other terms that are there. So fifth term is work input and sixth one work output. Now always remember, this effort is basically the input side. Effort is basically input and load is basically the output. Load is basically the output. Okay. So work input will be work input will be work done by the effort. So I told you input is the effort. Okay, so work done by the effort. Now formula for work done, force into displacement, right? So this is the formula. Now here force is basically the effort. I told you load and effort are basically forces. So instead of F, I will write effort, and instead of distance, I will write distance traveled by effort. E into dE. Okay, E into dE. Then work output will be work done on the load. Work done on the load, because output load is the output side. So again force into perpendicular distance, load into distance traveled by load. The formula for work output will be load into distance traveled by load. Is it clear? Next comes efficiency. Efficiency. Efficiency is the ratio of work output upon work input. Always efficiency output upon input. It can be power output upon power input or work output upon work input. So it will tell how much output is produced compared with the input that is given to it, and it will always be in percentage. So you'll have to multiply by 100. So you will have it in percentage. Okay. So the seventh term is efficiency, and the symbol that we use is eta. Okay. So efficiency is eta. That's the seventh term that we saw. Now take your book. So you can keep putting tick marks. I told you the other day, mechanical advantage definition will be ratio of load to effort. Velocity ratio definition will be, the velocity ratio is also defined as ratio of displacement of effort to the displacement of load. Now this paragraph talks about the three possibilities: force multiplier, speed multiplier, and change in direction. Then come to work input. Put a tick mark here. Work input is work done by the effort. Effort into distance traveled by effort. Work output, work done on the load. Load into distance traveled by load. Then comes efficiency. Work output by work input into 100%. So, okay. Now see this note. Due to friction and weight of the moving parts of the machine on a given design, its velocity ratio does not change, but its mechanical advantage decreases, and so its efficiency also decreases. So, always remember, velocity ratio will never change. Velocity ratio will never change. But mechanical advantage can change, because there is frictional force, there is the weight of the moving parts that can reduce the change the mechanical advantage. So efficiency, it is very difficult to get 100% efficiency. It will always be less than 100. Okay. So next comes principle of a machine. Principle of a machine. So the same that you had, principle of moment of force, that is the same here also. Principle of machine. Work output should be equal to work input. Work output should be equal to work input. This is the principle of a machine. Is it clear? So output energy, for an ideal machine, output energy should be equal to input energy. Now, there are two things an ideal machine and an actual machine. Now what is an ideal machine? Ideal machine is one, there is no loss of energy in any manner. Work output is equal to work input. Okay. What is an actual machine? Output energy is always less than the input energy and there is always some loss of energy. Okay. Output and no loss of energy, work output equal to work input, 2 points. Here output energy is less than input energy and therefore always there is some loss of energy. Okay. The next important thing is the loss of energy in a machine is due to following 3 reasons. So the question can be, what are the 3 reasons for loss of energy in a machine? What are the 3 reasons? First, moving parts are not weightless. Second, string is not perfectly elastic. Third, its different parts are not perfectly rigid. Okay, so some energy will go in overcoming friction, overcoming elasticity and overcoming the rigidity. Okay, so energy will be wasted in all these 3 forms. So you need to know these 3 reasons due to which loss of energy happens. So the note here says the most prominent loss of energy is overcoming force of friction between moving parts of the machine. Okay. The note says the most prominent loss of energy is overcoming the force of friction due to the moving parts. That's the most common. Okay. Now come to the next heading, relationship between efficiency, MA and VR. So these are the 3 important terms, MA, velocity ratio and efficiency. We are going to derive a relationship between them. Okay, this derivation comes sometimes. So please put a double tick and write derive. Okay, you have to study the derivation and as you watch this, I want you to note it down also. So according to the principle of machine, that's where you have to start. Work output is equal to work input. Now, just before we saw the definition of work input. Work output is load into distance traveled by load. Work input is effort into distance traveled by effort. So, output is load into distance traveled by load is equal to effort into distance traveled by effort. Now, what you do? You bring this E here. So, load upon effort and you take this DL down. DE upon DL. Okay. Now, okay, this is the condition for an ideal machine, but if you have to find efficiency, you have to start with the formula for efficiency, that is work output upon work input. Work output upon work input. So our output is load into distance traveled by load. Input is effort into distance traveled by effort. So I'll group these 2 and these 2. So load upon effort into DL by DE. Is it clear? Load upon effort I am grouping together, multiplied by DL by DE. Now load upon effort is what? Mechanical advantage. DL by DE is 1 upon velocity ratio, because velocity ratio is dE by dl. dE by dl. This is load upon effort, whereas velocity ratio is dE by dl. So what you have is dl by dE. That means it is 1 upon inverse of velocity ratio. So what is the relationship that I am getting? Efficiency is equal to mechanical advantage upon velocity ratio. So this is the relationship between efficiency, mechanical advantage and velocity ratio. If it's an ideal machine, MA will be equal to VR and efficiency will be 100%. But practically, none of the machine will be ideal. There will be always some loss of energy and so efficiency will be less than 100% in all cases. Is it clear? So this is the final conclusion. MA is equal to VR into efficiency. So as I told you, this derivation is important. As you listen to the lecture, I want you to note it down, write it down in your classwork notebook. And again, there are two conclusions. For an ideal machine, efficiency is equal to 1 or 100%. For an actual machine, mechanical advantage is always less than velocity ratio and efficiency is less than 100%. That is the conclusion. Now, the next topic is levers, but last year when they cut the syllabus, levers were cut. Okay, so I'm not doing it now. Let's wait and watch. If it is cut, then okay, otherwise I'll teach it little later. So after this, I'll be going to B part, that is pulleys. Okay children, hope you are clear with this. Thank you so much.